Now we have a better understanding of partition key and sort key. Let's focus on secondary indexes now. Why we need it is more important. So we have to first understand why we need secondary indexes and in which cases I would be using them. I would say in most cases you would use them and they have to be carefully selected, same like your partition key and sort key. I may want to re-emphasize here that whatever you want to achieve with DynamoDB, it will only work if you have done right data modeling. Data modeling is an exercise we will do initially before you actually implement the table to understand the access pattern, to understand the type of data which will be coming in, to understand the query pattern which will be there, to understand the performance requirement, and based on that you would be creating a table. So it may require more planning than your traditional databases, but the benefit here is that I could scale it to virtually unlimited capacity in terms of storage and in performance, and I can get high durability plus a managed service, so I do not have to worry about the different aspect of server management or database management at all. But you have to be thorough with your design. Okay, so this is my table as of now. I have some I have some items. I have to remove this word record. I come from that RDBMS world and that always comes to my mind. So why we need indexes? Let's first focus on that. Why is more important rather than what or how? So this is my table, which is having a composite key, primary key equal to partition key plus sort key. Partition key currently is a title and sort key is the author. Let's say we selected that, so that is also possible. We didn't go for addition and maybe we just said we would use sort key as the author. Hopefully this would be unique combination. I'm just hoping. But let's say now we start asking some questions to table, right? While we are storing data, maybe we have to process that data and understand some patterns or understand or some answer some queries. So question comes, which book has 18 chapters, right? Now let's consider that you have to answer this question now by looking at the table now. So you can directly go to this particular record and say, okay, you have 18 chapter. How you achieved, how you come to this? You checked where is the numbers. This is not a number. This is not a number. Numbers are here. Numbers are here. There is no number. So I scanned all the items here. And then I come to the result that, hey, this one has 18 chapter. This is not an efficient way of searching a database or a table. So what we are having here that we created some of the indexes or the methods of query which is not efficient to answer a question like this, which book has 18 chapter. It has to go through every item, every attribute and then come back with a value that, hey, what is the value of book chapter? So this is not efficient. Or if I ask some rational questions like or relational question like give me all the book of price less than $15. Again, not a very good design of my table. I can still answer it. I would tell you how to answer this question through database, but it is not a very efficient design. That's why we need to create indexes. And these indexes are referred as secondary indexes. So what is my primary index? My partition key is my primary index. And then based on my access pattern, based on my business requirement, based on the attribute which my customer would be searching a lot or my application would be searching a lot, I would be creating secondary indexes. Let me give one more example to bring home the point. What I have here is a DynamoDB table which I created, which name is geometry. In the table, I have selected my partition key as color. So any item which is coming up based on their color, they should be stored in different partition and they should be further sorted based on the shape we have. And let's say we have 3 partition just for sake of understanding. And these are the items on my left, which I want to store here. And this here is the magic hash function who would perform the distribution of my items as they come into my table. So I insert records, insert items, and then this hash function would then read that, store it. So maybe all same color items are going into one partition because my partition key is color. So as you could see, all my items are stored same color item in the same partition, like here, black, red, blue, green, that's done. Now, there are chances that I may have multiple items of the same color like here. And these items are now sorted based on shape. So circle first, then triangle, then square, circle first, then triangle, and then square. Just an example, right? Hope you are getting the idea. So this is how my sort key is being used to store this item. Right? If I go ahead and ask some question to this database, hey, database table, give me how many purple color shapes we have. So my query is on a partition key or the primary index which we have. So that is good for DynamoDB because what it can do now, okay, what you want a purple color information. Color is my partition key, and I know that in first partition all my purple color items are there. So it has to only go here and not on other partition and give you the details of all the purple color shapes we have. Right? So efficient way because it knows where all purple color items are. I ask a second question. Give me details of purple color square, right? So two things we have to look for. First is purple color, and then second, I am looking for information of a square. So this time also, I would go ahead, search everything, or DynamoDB would search in this partition and then use sort key of shape to identify the square and deliver me the details of it. No problem at all. Efficiently, I am getting the result. But I change my question now. I say, how many squares we have, right? Square is not my partition key. So DynamoDB can still answer this, but what it has to do, it has to go to every partition, every item and ask, are you a square? This one would say no, 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 yes. So we have one square. This one, no, 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 yes, second square, third square. So it would still return me the result of 3, but it is not at all efficient. I have just few items here. What if we have multiple items and multiple attribute? It would very complex. It will be very complex way of going to every item and looking for the information. So we need an efficient way. So to summarize what we have here, current primary key is not efficient for the question I asked. That's where global secondary indexes comes into picture. So I'll now create something called a global secondary indexes. Before I go ahead, indexes are an additional way of performing efficient query or search or operation within my DynamoDB table. So we call them secondary indexes. Right. Secondary indexes are of two types. One is called global secondary index and second one is called a local secondary index. Right. I'll show you both of them, and local secondary index can only be created at table creation. So obviously I did a mistake. I have to delete that table again and I would recreate it, and that's why I'm saying that I have to be very thorough with my design. I may be sounding like a broken record, but I cannot emphasize enough how much is important to design your DynamoDB table efficiently. So that's why that table which I already have in my console won't work, but I will create another table and then I'll tell you how to utilize this local secondary indexing and global. And let's first talk about when to use which one. So let's say this is my table. The data is there, color is there, sort key, shape. Now I know that my questions are always coming for a shape. People say how many triangles we have, how many circles we have, how many squares we have. So let me create a global secondary index, global secondary index. And this time I would create a global secondary index and say, hey, you would be a global secondary index called shape. My primary key is this. My data is currently stored in the format of color, and that's there. When I say I want to create a GSI, short form is GSI for global secondary index, what happens behind the scene, consider that a new table is created for you. And in that table, your items are again rearranged, but this time this table's partition key would be shape. Hope you're getting the idea. So all the item which you currently have, consider that you got one more table created, which is based on the GSI you specified, which is shape, and all these items would be then rearranged and stored into this GSI. And this time, what will we seeing? We seeing all triangle in one partition, all circles in one partition, and all square into another partition, because my key was a shape. Hope you get the idea. Sort key is optional. I may say I don't need a sort key. If I wanted, here I could have said sort key is color. So they would be then arranged within that partition based on the color. So that depends on what I want. But GSI would be creating a separate table behind the scene, and you would be able to select that what would be the new partition key. Think like the same data has been rearranged for you in a pattern based on shape as a new partition key, right? Another thing which you could do, you could say, I may have an item here. Let's say this is my item, and then this is my item is my triangle. There is a color, let's say purple is the color of that. Maybe this was created in Dubai, and this was having a date creation of, let's say, of 18th of February, and this one was created by Ashish, something like that. I could say I would be not needing all the attribute in my GSI. I just need the attribute of shape and when this was created, that's all. So what we can do, we can project only the required attribute rather than storing the all attribute. So all these attribute would be stored into my main table. Main is not the official word, but to explain I am using it. So all my data, all the attribute of that item is stored. And when I said that my GSI would only have shape and date, so my shape would come and then date would be also created, whereas here I would have all this information. So you could project only the required attribute within your GSI. You do not need to carry all the attribute with your GSI. I hope this thing is clear. So let me go to console, and we would then create this table, and I'll show you how we can create a GSI associated with that. So that table is there, all books, let it be. I would go ahead and create another table here and call it geometry. So my table is geometry. Partition key I am using here is color, which is a string. I am using sort key as a shape. Let's say this is also string, no problem at all. And now I have to deviate from the default setting. See this thing here? In default setting, there is no local secondary index created. There is no global secondary indexes created, right? This is also important. Can it be edited after creation? So GSI can be edited after creation also, no problem at all on that. But if you look at the top here, which says local secondary index, they cannot be edited after creation. I'll talk about them, but let me first focus on global secondary index. So I won't go with default. I would say I want to customize. Okay. All right. You want to customize, fine. What you want to customize. So here are my option to create a secondary indexes. Let's read the information. Secondary index let you query the data in a table using an alternate key in addition to query against the table's primary key. So it is an alternate way of query. DynamoDB doesn't require that you use indexes, but they give you application more flexibility when querying your data. After you create a secondary index on a table, you can read data from the index in the same way as you do from the base table. So this is the main word, base table, and DynamoDB support two kind of indexes, global and local. Let's talk about global. Global index, an index with a different partition key than the one on the base table. A global secondary index can have a simple or composite primary key. Very complicated English. Let me explain it here in simple. I say I want to create a global index. Done. All right. If you see, this looks similar to what I had for my table creation. Think like you are creating another table, but the data wouldn't be inserted directly, but it would be come from your base table. So this time I say, okay, I want to have this only as a shape. And that's all. I could go ahead and say, this is my shape index, and maybe I could give it a name just to identify, which says GSI. So this is my shape index GSI, global secondary index based on shape. And if I feel okay, I could just say create index. Done. If I want to create more indexes, no problem at all. So this is my one index. I could go ahead and say I want to create another global index. Maybe my Data would be searched mostly based on date. So I want to have it as a primary partition key, and I want to have a way to sort based on the city of that shape. So now I am creating a date city index, and again it is a GSI. So I just given a name to identify it. And here is the projection I was talking about. I could say I want to project all the attribute, which may not be efficient, unnecessarily creating a bigger GSI. Or I could say I only want keys to be projected, right? You know that we store data into a key and value format. So I could say only keys are required. I do not need values in that. Again, it depends on your use case. And you could say I want to include a specific attribute only. So I want to attribute, maybe add an attribute like date, city, and maybe the price, but nothing else beyond it. My actual item may have hundreds of attribute, but here I would have very specific attribute. So it is up to you what you want to include. That is purely your decision. For simplicity, I am keeping all, but you have to be designing this efficiently to have a better performance and utilization of your data. So I'm creating an index. So I have two indexes created. Now the difference is one index is only having a partition key. Another index has a partition key and sort key, and I can create up to 20 global secondary indexes. No problem at all on that. So GSI can be up to 20, right? Now, GSI are flexible because they can be created anytime. So let's say you tried your best to accommodate all the possible query patterns for your request, but none of the query pattern is matching to what your current requirements are. So that time you could go ahead, create a GSI, query the data if you need to, and then maybe delete that if you do not need it anymore. So that is giving you flexibility that you can add them anytime, and remove them also should not be a problem at all. But local secondary indexes are a little different. Let me first explain a local secondary index, and then I'll come back here and create a local secondary index. Right. So global secondary index hopefully is clear. We are creating a different table altogether, and in that we are storing the required attribute which you selected. Let's focus on local. I expanded little more item details into my example now. So now I have circle created on 20th Feb in London, black circle created on 3rd October in Dubai, blue triangle 14th May in Prague. Done. Now I go ahead and say, hey, I want to query something. All right, let's go ahead and query. So we say query. I say how many purple color items for London. Now what I did, my table is having a partition key of color, sort key of shape. So I'm still making a request for a purple color item matching this. So DynamoDB would know that which partition to go and check the data. But now I asked for an attribute which is not indexed. So what it has to do? It has to go to all purple color item and say, are you from London? Are you from London? Are you from London? So this is not efficient design, right? In this case. Or I ask another question which says, give me details of purple color items on 18th March. Again, same thing. I would know where the purple color items are, but I have to still go to every item and check every attribute. This is not very efficient. Why it is happening? Because one single partition may have lots of items. So a single partition may have lots of items, and we need an efficient way to find specific item. That is where local secondary index is useful. So its name is local secondary index, LSI. So LSI is specific only to that partition, and that's why it is called local, right? It is giving you ability to search within the same partition or index data within the same partition, and that's why it is called a local secondary index, and this cannot be changed after table creation. So saying it again, you have to design properly what is going to be a local secondary index, and local secondary index would not have a partition key. It would use partition key of the table and then would add additional sort key of your choice. So that's what we would be creating here. So DynamoDB support two kind of indexes, GSI and LSI. GSI index with a partition key and sort key that can be different from those on the table we just saw. Local secondary index, an index that has the same partition key as the table but a different sort key, and it would make more sense when I show it to you in console. So I come here and say I want to create a local index, and see this, I am not seeing an option to use partition key. Only thing I can do is sort key. Whereas if I cancel and show you global index, here I have option for partition key and sort key also, right? So hopefully this difference is clear to you. So I would go ahead and say I want to create a local index, and what would be then primary key here? What would be my partition key? It would be the same as of my table. So in my table, whatever I have created as my partition key, it would just add additional attribute to make it a LSI, a additional sort key will be created. So maybe I want to say it is going to be color, and sorry, color is already there, so I won't use that. I would just say here that it is going to be date. So what it will actually create for me, it will create for me a shape date index, not data, sorry, date. So shape date index is created for me, and this is my LSI. Again, I have a choice to project everything or project only few attributes from that item. So it is up to me. So I can create an index like this. I can create more indexes, local index again another one, and what would be that? Maybe this time I want to have it as a city, right? So this one is again, technically it is what? It is my color. Sorry, I made a mistake, I guess. So color city index, let me quickly check, sorry for that. So what was my, yeah, partition key was color. So let's correct this mistake right now. Even if I have not specified, only the name has to be changed. Actually, it is still using the same information. So I will just change the name. Technically, it is still using color as the primary key there. So I selected color, and then I am creating another local index here. And this time I am saying city is going to be this, and that will be my color city index, and I would call it a LSI, and done. Now I have created two local indexes and two global indexes, right? So hopefully this is clear. Why we need it is clear, and how to create it is also clear. You have to be very thorough in understanding differences between them, and if you are preparing for exam, there will be some question which will check your abilities on these understanding of local or global indexes, right? So global index, when you query, the queries will run across all partition because the name says global. Whereas local, they would be used to query data within a single partition. That completely makes sense. Global secondary index have no size limitation, right? Because they are global and it is DynamoDB global size, so it is no limitation in terms of size. Local secondary index cannot exceed 10 GB. Why is that? Because the partitions which we create, it cannot go beyond 10 GB, and if it is stored within partition itself cannot go beyond 10 GB. So that is a limitation on a local secondary index. Also, when I am creating a global secondary index, basically I would have a base table, right? And I would have a GSI created for me, which is also a separate table. And what I can do, I could say base table, you would be requiring 100 reads and 200 write performance. But my GSI, you do not need that much of performance. I will give you 20 read performance and 50 write performance. I'll explain read write performance, but just consider that the throughput or performance setting you are configuring, it can be different for base table and it can be different for your global secondary index, because technically they are two different indexes having similar data, but technically they can both have their own separate provision. Throughput should not be a problem at all. Whereas if I'm talking about the local secondary index here, local secondary index would share the throughput of the table, right? So if you have a partition created and that has some throughput, as this reside inside the partition, it won't have its separate provision throughput. It would utilize whatever is configured on the table level, right? Hope this thing is clear. Read consistency, only eventual. What I mean by that, this is my base table, right? Sorry. clear this and draw this again. Let me use a black color. This was much efficiently looking here. So this is my base table. And once I commit something to base table, then it would start reflecting into my GSI, which means if I made the change right now, eventually it would be reflecting here also. And that's why my read are always eventual, which means I may still get stale data, right? But in case of local, as it is still stored on the same partition, it can be strong or it can be eventual. You decide based on the parameter you specify in the get item, and you would get either strong or eventual, purely decided by you. But in case of global secondary index, it is always going to be a eventual consistency. GSI can be more, 20. Now, if you think that what about after 20, I would say then you are designing things wrongly. I've seen a lot of use cases where people use a lot of indexes, but I still have to find some design where we need more than 20 indexes. If you're doing that, if you're trying to treat your DynamoDB as a SQL database, then you are doing something fundamentally wrong. So 20 is a good enough number. It doesn't mean you need to have that many. And as it is dynamic, because these can be created anytime, deleted anytime, you may create indexes temporarily and maybe then later you delete it, but 20 is a good enough number, right? So this gives you flexibility for the use cases when ad hoc request comes, right? Somebody is asking you some data which you have not stored based on some indexes, or for which you have not created index, and you still have to satisfy that answer. Maybe you will use global secondary indexes in that case. But common patterns, you would address them through local secondary indexes, and you can have up to 5 local secondary indexes, nothing beyond it. And the thing, they can only be created and deleted at the table time. You cannot separately go ahead and modify them. So be thorough with what you want to plan for your local secondary indexes, right? So I hope this thing is clear and you have better understanding of how indexes work and why we need it. We would talk about more settings of DynamoDB related to its performance, throughput, and maybe some features like DynamoDB stream and then TTL values. So that is coming. Let me stop here and I'll speak to you into the next section. Thank you.